Hello, in this video, we will continue to introduce the heap sort. In the preceding video, we introduced the heap data structure. Heap is a complete binary tree with the order property. We introduced how to store a heap using an array list, how to find the elements whose parent and whose left child or right child from the array list using the index. And we also introduced how to add an element into the heap and how to remove an element from the heap. Now we're ready to define this class for the heap objects. A heap is a container object. It can contain the elements. The elements is organized in this complete binary tree with the order property. And this is the heap, and the element type is E. And there's three constructors here. The first is the no-arg constructor. You can construct the heap using the no-arg constructor, and how you can compare the elements, you're going to use the natural order, use the comparable interface. So if you add the strings into the heap, the strings compared to method is used to compare the strings. If you use numbers, the numbers compared to method is used. You can specify your own comparator and using the second constructor. So this is to add a new element into the heap and remove the root from the heap, get the size is empty. And here is the implementation. This is how we implement this is the heap. And so those are the private data fields. The internally, we use the array list to store the elements in the heap. And this is the comparable, the comparator. So for the no-arg constructor, we now use this comparable interface. And so this is how we compare it, and we get this comparator from the comparable interface. And this is the comparator C. Now, and here is the add. So how do you add? And you're going to put this element here at the end of the array list. And now from here on, you're going to see find the parent index. So here is to find the parent index. It is the current index minus 1 divided by 2. So this is the current index for the new element you just added in the array list. And here is C that compare this, the element at the current index with the element at this parent index. So if it is greater, then you have to do swap. That's how you go move all the way up until that it's in the right place or it reaches to the root. All right, similarly, you can implement the remove the root method. And this is the get size. It's a list dot size and is empty as list dot size is equal to 0. Now you can use the heap class to implement a heap sort method. So this is the heap sort method. Heap sort, we're going to sort this list and using this comparator C. And another heap sort, this is simply here, heap sort a list and using the default comparable interface. You can invoke here is heap sort, invoke this one right here, heap sort, and with this as your comparator. And here's the list. Create a heap using the comparator, add all the elements into the heap, and remove the elements, the largest one first, and put it and back to the list in this order. So after all this is done, your list is sorted. Let's look at the time complexity. The time complexity is this here. What's the time to insert one element? It is dependent on the height of the heap. And what is the time to remove an element? It's also dependent on the height of the heap. So for each operation, and so you're going to take in the worst case and the height of the heap. So what's the height of the heap? And the height of the heap, it is log n. N is the number of the maximum number of elements in the heap. So in the worst case, you have this order of log n for the height of the heap. You have n elements, and now each element, when you do for each element, when you do the add and remove for each operation, it is order of log n time. You have n elements, and this is total is order of n log n time for insertion and deletion of the n elements. So the total time for the heap sort is order of n log n. Thank you very much for watching this video. See you on the next video.